So let's look at those three categories of errors. The first category is syntax error. Now, when you're programming for the very, very first time in your first few days or even weeks of programming, you may come to the conclusion that syntax errors are the worst because you're going to get a lot of these unless you study the syntax very carefully and make sure you type everything in correct. But the syntax error is in some ways the easiest to find because Python will tell you exactly where it happened. And that actually makes them a lot easy to fix. Usually a syntax error is caused by typos or omitted punctuation. Like you forget to type a comma, for example. You go ahead and says, oh, I can't execute this, I don't understand it. It's essentially very analogous to a syntax error or a grammatical error in using a human language. You just say something doesn't make any sense. Like you get verbs and nouns in the wrong order. Here's a very simple example. If I say print A, B, C, and there's no commas in between the different arguments, Python will say, oh, syntax error. But usually, if you get a syntax error, just look at the punctuation. You had not enough commas or too many commas, or you forgot the colon where you were doing a function definition or something. So this is one category. It'll bother you at first, but if you just learn the syntax carefully and study it, you'll learn to appreciate that syntax errors are not the worst. Now let's look at category 2, that's runtime errors, which in Python we call exceptions. So exceptions actually come up a lot more in Python than they do, say, for example, in C++, or C++ especially. And here's why. Because in Python, you can use any kind of variable in any context. You can pass any kind of data to any function, and it'll go ahead and do it. There's really very little type checking in Python. So what happens when you try to do something that's incorrect? Well, it's not detected until you actually try to run the program. And then when you try to run the program, it will raise something called an exception if you can't do it. Literally what an exception says is the computer saying, I don't know how to do this. You're asking me something that is not physically possible. So what I have to do is I have to immediately terminate the program because you told me to do something I couldn't do, and then you didn't tell me how to handle it. Now, this might not seem so terrible, but it's something professional programmers have to avoid. For example, what would happen with Microsoft Word if there was an exception in the middle of Microsoft Word, and instead of Microsoft Word telling you, oh, you have to re-enter the file name, or oh, you used the wrong command, try this, Microsoft Word just quit. And if it did that, and I think, I don't want to badmouth Microsoft, but I suppose there have been some versions of some software might have done that at some point. But if that happens, you think, oh, their software is terrible. It just bombs out in the middle of the program, and it didn't tell me how to recover, and it didn't even end politely. It terminated rudely instead of politely without even telling me what the problem was. That's what will happen with exceptions that are not handled. So later on, we're going to talk a lot about how to handle exceptions, because that gives the programmer the option of either continuing or at least terminate with a nice message saying what went wrong. But here's an example of an exception, a very common one when you're doing arithmetic or doing math. If, for example, you let the user enter some variables and you're going to carry out division for them, and you ended up, for some reason, trying to divide by 0, basically the computer says, no, I can't do a divide by 0, I can't even do it. It's grammatical, right? It made syntactic sense, so that it wasn't like a missing comma, but no, you were literally trying to do something that was impossible. Or, for example, you tried to open a file for reading, but it doesn't exist. So it's the computer's way of saying, oh, I can't do it, and then Python is passing that along and telling you what it is in terms of being an exception. And there are far too many to list, of course. There's a few common ones are zero division error, or name error, or file not found error. But if you want to find a full list, you can find them at docs.python.org in the documentation on exceptions, and you can find them all listed. There are a certain number of built-in exception types. So you think that's bad. Now we come to the most bothersome kind of error of all. And it may sound innocuous, but it's actually the worst. because the final category is a program logic error, sometimes just called a logic error. Now, what happens with a program logic error? It's syntactically correct. So you don't get a syntax error. The grammar is fine. There's no exception raised, so the computer was not asked to do something it didn't understand. And Python just went ahead and ran it, didn't complain. Oh, okay, this fine, go ahead. But when you ran the program, things happened that were not what you wanted to happen. So maybe your program's supposed to add up a column of small numbers and you get the answer 1 billion or something. I was like, okay, wait a moment. It went ahead and ran it, but I know that result is completely wrong. And this is such an important class of errors that companies, Microsoft, Google, whatever, they have entire departments dedicated just to find these errors before the users do. They're called testing departments or quality assurance, and their whole job is to find these errors, because if they don't find the errors before the end users find the errors, they will get nasty, nasty letters and a very bad reputation. So there are thousands of people employed just to run tests to detect bad results of the program before anyone else does. And again, these bad results are called program logic errors. Syntax is fine, computer didn't complain, but it went ahead and did something that was totally wrong. Now here's why these errors are really the worst of all. Let's say you have a 10,000 line program. Well, that would be long for Python, but you might have a 1,000 line program. And it goes ahead, runs without a syntax error, but the results that you see on the screen are just completely wrong. Or you have specifications from the person who's contracting you, the program must do A, B, and C, and then it doesn't do A, B, and C. It doesn't do any of those things. It just doesn't behave at all correctly. Well, you got a 1,000 line program. What are you going to do? Well, if a syntax error would tell you exactly where it was. If it was an exception, up would come a message telling you what happened. But with a program logic error, it could be anywhere at all in the program, anywhere. So program logic error may sound like no big deal. It is actually by far the worst. It's the one to which programmers dedicate most of their time, in many cases, to solving. Now, what we call the process of fixing these errors, debugging. You may have heard of debugging. Debugging usually isn't fixing syntax errors. That's not really debugging, that's just a matter of syntax. Exceptions you deal with by writing exception handling code, which we'll get to. But when programmers talk about debugging, this is what they're talking about. Now, I'm going to take an example here. Let's debug a very, very simple program. And this is a program that's already run, but I'm going to explain why this program might need to be debugged. So here's a Fibonacci program, and it prints out Fibonacci numbers, but it doesn't print out all of them. It prints out the Fibonacci numbers starting with 2. Well, I might want to print out all the Fibonacci numbers starting with 1 and 1. And this is where specifications really matter. And drawing up specifications, handing them to programmers is really important, because this prints out some Fibonacci numbers, but not all of them. And if the specifications say you have to start with the first Fibonacci, it is by definition a bug because it didn't do what you were told you needed to do. But I'll show you a process of analysis by which we fix this. So let's go over, re-enter this program, and try to figure out why it won't do what we want it to do. Okay, and this, if I enter this correctly, it should print out all the Fibonacci numbers but the first 2 Fibonacci numbers. So it sort of works, but if the specification said it needed to print out all the Fibonacci, it's actually a bug. But programmers like to say, well, it's a feature, not a bug. No, no, no. It's not a feature if the specification said it's not a feature. So let's run it, print out Fibonacci numbers up to 1,000 or so. Okay, well, it started with 2. Maybe that's okay, but if this, again, the specs say start with 1 and 1, it's a bug. So how do we fix this? Well, let's go back and edit this function. Okay, it's not letting me copy and paste, but We'll fix that later. Right now, let's re-enter this. And you notice how we start with a and b both equal to 1. We can initialize variables differently. If we'd started out with, say, 0 and 1, it would be one step further back in this loop. So let's initialize differently. Let's say a equals 1, but b equals 0. So we're going to start with different initial values that should put us one further back in the Fibonacci series. And otherwise, this is the same code. And let's see if it behaves differently, because all we're trying to do here with program logic errors is change its behavior. Okay, so there's syntax error. Presumably there's no exceptions. Let's run it again and see if we like how it behaves. Okay, so this is closer, right? We fixed part of the problem because now it starts with 1 instead of starting with 2. But let's look at that code again. What else might not be correct here? Well, notice if you get into the middle of the while loop, it steps ahead in the series by going a comma b equals a plus b comma a. So it does the advancing to the next series, and then it prints a result. Oh. So in other words, it goes through the series and then prints the result. Well, what if we were to do this in reverse order? What if we were to print out the current state of the Fibonacci sequence, which is the value of a, and then advance it? Well, would the results be different? And so to debug a program, that's what you're doing. You're looking at each step of the program and you're saying, did that do what it was supposed to do at that point? What if I did it in a different order? Or what if I did something different? So once again, we'll redo this program. We'll keep everything the same, but we'll change the order that we do things. And that's a common thing programmers do. It's like, yeah, did I do things in the right sequence? So first of all, I'm going to print the current state, and then I'm going to advance it through the Fibonacci sequence. And this is how we do it. This should work. It took it, so no syntax errors. So go ahead and say Fibo 1000, and let's see what it does. What numbers does it start with? Oh, okay. And it finally fixed the problem. Because finally now, this function will start with 1 and 1, so 2 instances of 1, and that's actually important to be the correct statement of the whole Fibonacci sequence. It must start with 1 and 1, and the specifications say that's what it has to do. It's not debugged until it behaves correctly. So very simple program, a very simple function really, and we actually debugged it. Now this brings up the whole subject of debugging tools, and yes, even idle does come with some simple debugging tools, but I'm not going to go into them deeply except to describe what they are. You'll see some menu options, or you'll see some tools described as debugging tools, and if you didn't know better, you might think, well, you just click on the program, or you click on something and you press a button and boom, it's debugged. And guess what? It doesn't work that way. And the trade, that's what we call a magic bullet. No, it's not a magic bullet, because debugging is a process of analyzing the program. It's analyzing what the program did. It's like, well, did it do the wrong thing here or do the wrong thing there? And what should it have done? Did it do what it was supposed to do there, or did something else? So there are debugging tools. There's debugging commands on a menu, but they don't magically fix anything. All they do is allow you to step through the program more slowly, and then at each point you can examine what the data is, or what the variables are equal to at each point. And then you can think about, is that what it's supposed to be at that point in the program? And that is useless to you unless you understand the program, which means either you wrote the program or someone else wrote it and you read through their code and you understood what it was trying to do. So debugging tools are a convenience, but it doesn't really save you from the hard work of trying to analyze what went wrong in maybe that 1,000-line program. And so in a nutshell, this is the hard work of programmers. A lot of what they do is they look at thousands of lines of code and say, where did that go wrong? But that's part of the fun, I guess. You have to enjoy problem solving to really be a programmer full time. And this is a lot of what you do. And this is what debugging is. Now, before we leave this subject, I want to spend some time on running a program from the command line. Now, up till now, we've done everything in idle, the environment. We can run a lot of stuff there, but it's important to be able to create a program, save the program, and then be able to run it from outside the Python interactive development itself. This is very important to a lot of people, so you can have a general purpose program. So what we're going to do is still take a very, very simple program and then show you how we can run it from the command line with a Macintosh, which I have. What I'll do is I'll start up the terminal application, which is like a DOS box, and it will allow me to type in this command on the command line and use a Python program running outside the environment. Okay, let's do that. Let's re-enter the Pythagorean theorem program, which is going to calculate the hypotenuse. I use that a lot, but it's a nice simple program. And to demonstrate all of Python's wonderful features, we're going to give it a doc string, which is a kind of help. It's a comment using the triple quote mark feature, but it will also provide us some free online help, as you'll see. So once again, we see our favorite little program. We're going to enter it again. Take the square root of a squared plus b squared. And let's see if it works. This should produce 5.0. Yes, it does. So once again, we're in this position. We entered a function into idle, but we want to save this. And we want it to be in a program file where we can run it anytime we want. So we copy it. We open a new file and paste it in. So there's the function definition, but we also want to call it as part of this program, and so we will call it 3 and 4. That's fine, just to see that it works. It's a really simple little program. And we can run it from here. It'll ask us, do we want to save it? Let's save it as pythag.py. Now, when I save a Python program, I will need to give it a py extension. That is critical. So pythag.py, it will save it in my documents file. And go ahead and do that. I mistyped Pythag. I must have typed it as pyhag, apparently. Yes, I did. Let's go back and fix that. Print not pyhag, but pythag. Now, this is an example of fixing a syntax error. So what is syntax error? I mistyped something, generally. I did a typo. Let's run and save it again. See if it likes it this time. Oh, it likes it, because I didn't mistype anything. But yes, so you saw syntax errors demonstrated very effectively in that scenario. Now what we want to do, it's saved it in my documents file, so I'll bring up my nice little terminal application. I'll change directory to documents because that's where it told me it saved it. So I'm in my documents directory. Let's see what's in here. Is there a pythag.py file? Yes, there is. So now I should be able, if I want to run from the command line, and let's make this a little bigger. If I want to run from the command line, I should be able to say pythag, or Python rather. We're using this name a lot, sorry. Sorry for the alliteration here. So I should be able to say Python, then I give it the name of the program file, including the py. So Python and pythag, which is for Pythagorean theorem, and then .py, which is for Python. Python, name of the program file, which includes a .py, and it ran. So it does work. So I was able to run it from a terminal, in effect. So I'm outside of Python itself, but I'm using Python to run a Python program. That's exactly what I wanted to do. Now, as long as we've gotten this far, we can do something new that is extremely useful, and I believe this is also tested on the MTA exam. We can do command line arguments. And command line arguments are extra arguments put on the command line when you type in a program name. It's sometimes very, very useful. So we want to be able to access those arguments from within our program and then do something useful with those arguments. Here's how we do that. First of all, we're going to import the sys package. Now, I'm going to say a lot about importing in the last lesson. Basically, what it's doing is bringing in like a new library of special abilities. And I'm going to use one of those. We're going to see a lot of those in the final lesson. But this time I'm bringing in a special object actually called sys.argv. And sys.argv is a list. It's very important to know how it's comprised. The first element in this list will be the name of the program itself. So argv will always be at least one element in length. It will start with the program name. If there are any other arguments on the line, they'll be passed in as argv1, argv2, argv3, etc. Remember, Python is zero-based indexing, but that first element is just the program name. So let's go back and write some code that takes advantage of this. What we're going to do, again, we have to import sys, which is a package. We'll talk a lot about that later. Then we'll look and see how many there are. So remember, the len function takes the length of any list. And if we want to use two arguments in addition to the program name itself, argv is going to have to be at least 3 elements in length. It's going to be the program name, and then it's going to be the 2 we pass it. If there are fewer than 3 arguments, then we're just going to arbitrarily set a and b to 1 and run Pythag on that. But if there are 3 arguments total, meaning we have name followed by the 2 pieces of data we're going to pass to it, then we can pass those to a and b and run our function on that. So to do that, what we need to do is go back to our program file. We have our function definition. We're going to leave that in. And again, it's giving me some problems with copy and paste, so let's get out of there. Let's copy this again and reopen the file, put that in there, and then what we're going to do is we're going to go ahead and type in this other code that's going to access the command line. So we will do the following. We'll import sys, which is like a whole new library of cool stuff that we can use. We're then going to access argv, which is a list containing everything on the command line. And if that is at least 3 elements in length, we'll do the following. We'll set a variable called a to float sys argv sub 1. Give us the first argument after the command name itself. We're going to set b to the second argument after the command itself. And if we don't have enough, we'll just say set a and b to 1. And in either case, what we want to do is then print Pythag a comma b. Hopefully I've typed all this correctly. We will save it. We'll save it again under pythag.py. We can also run it from within Python. Now what happens if we run this from within the environment and it looks for command line arguments? Well, it's only going to have 1. So it won't find 3 because we're running it where there isn't these extra arguments. So what it did actually did exactly what was correct. Because what it did is it said it couldn't find all these arguments. There's no way you can have that from within the environment. So it went ahead and did the else, and the else put a and b equal to 1. And the Pythagorean theorem will give you the square root of 2 under that condition, which is actually what we got. But what we're really interested in doing is saying, can we now run this from the command line? So if we say Python, again, we'll do pythag.py. And fine, it still didn't have enough arguments, so it went ahead and did the square root of 2 by setting a and b equal to 1 each, and then doing that calculation. But now, let's run it again, and it's now going to access 2 completely new command line arguments. We're going to give it 30 and 40. And what it should do is use 30 and 40 in that calculation. And actually it did, because it turns out if you run the Pythagorean theorem on 30 and 40, the correct answer will be 50. It did exactly what it was supposed to do. So we've learned how to use Python from the command line, use a command line version of it. We've learned how to type in additional arguments called command line arguments. And we've learned how to use something called sysargv to access a list containing all those arguments. One other thing that we want to be able to do from the command line is use something called PyDoc, which will give you documentation from the command line and will give you this interactive help. And if we're in the idle environment, we can say help, give it the name of a function or an object or a class, and it will give us help on that. It will tell us all the things that are available. But we can also get this from the command line. And the way we do that is we say PyDoc space and then the name of the program without py. It gets a little inconsistent. So to run the program, you've got to say .py, but PyDoc, you don't use it. So therefore, we will use PyDoc. Let's get a new line. So we'll use PyDoc. And now we give it the name of the program, no.py. Again, inconsistent, but you just have to get used to it. So PyDoc with Pythag should give us the help that's available from the program. And that's what it did. So Python automatically generates certain documentation for any program. And what it does under functions, we wrote a docstring for the Pythag function, and this is where that docstring would be printed. We could have had a much longer docstring. And again, we could have put in Mary had a little lamb or the Gettysburg Address or just something helpful, something useful. Whatever that docstring is, it would be printed at this point. Now, it's a little tricky getting out of here if you don't know how. You have to remember, at least in this environment, you press Q, goes back to the command line. I think that Q always works with PyDoc to get out. So let's summarize what we know in this lesson. I'm going to focus once again on the three kinds of errors because this really is important stuff. A syntax error, you just enter something that is not grammatical, and it's usually either a typo or you use the wrong punctuation. Then we have runtime errors, which are called exceptions. And you typed in something that syntactically correct, but you're asking the computer to do something it isn't willing or able to do. It's like, divide by 0. No, I can't do that. And unless you handle the exception, as we're going to do in the next lesson, it just terminates rudely. For an amateur programmer, that might be okay. The more professional you are, the more you just have to handle things like that if you can anticipate them happening. And finally, the worst of all is program logic errors. Doesn't sound so bad because syntactically correct. Python accepted it. It ran the program. There were no exceptions. It didn't terminate. But all the results were wrong, and you don't know why. And that's why program logic errors are the ones we're usually talking about when we're debugging the program. And so, if you become a professional programmer, welcome to the wonderful world of debugging, because you're going to have to do a lot of it. I will say, however, the more careful you are as a programmer, the more you plan out your code, the more you study the language and work carefully, the more, hopefully, you won't have to spend all your time debugging, and I hope you won't.